For time greater than or equal to 0, the height of an object suspended from a spring is given by this equation right here. What is the average height of the object from t equals 0 to t equals 2? When you're finding an average height or any average value, what you do is, we'll say in this case average height, then it's going to be equal to 1 over b minus a. That's what makes it average right there. The integral from a to b. And right here, the integrand is going to be whatever the formula is for the thing that you're trying to find the average of. So notice the connection from here to here, and that's why I like to write it out this way initially. Now let's substitute in the things we know. We know that this is our a and this is our b right here. So we end up with 1/2. And from 0 to 2 of our height, which is 16 plus 7 cosine pi times t over 4, and then end that with dt. Now we can find our antiderivative. Just keep that 1/2 out front. Antiderivative of 16 is going to be 16t, and then you can use the u substitution on this, or you can remember that when you have something multiplied by the variable inside of a trig function, you're going to divide by that same number right there. So if I divide by pi over 4, that's the same thing as multiplying by 4 over pi. So I'm going to take this 7 and multiply it by 4 over pi, which gives me 28 over pi. And then the antiderivative of cosine is sine, and then this pi t over 4 stays the same. Now I want to evaluate that antiderivative from 0 to 2. So I have 1/2 out front, and then I'm going to have 16 times 2 plus 28 over pi times sine of, put 2 in for the t, and you get 2 pi over 4, which is the same thing as pi over 2. So that's my antiderivative evaluated at the upper limit. Now I need it to subtract the antiderivative evaluated at the lower limit. So if I put 0 in there, then that term goes away. You have to be careful when you have trig, because sometimes when you substitute in the 0, it goes away, and sometimes it doesn't. So if I put 0 in for t, then I get sine at the angle 0. The sine at the angle 0 is 0, so actually we're just subtracting 0 there. But you need to check that out every time. Now I want to distribute my 1/2, so if I multiply the 1/2, it's going to cancel with this 2 right here and leave me 16. And then if I multiply this constant out front by 1/2, then I'm going to get 14 over pi, and sine pi over 2 is 1, so we're just multiplying that by 1, and D is your answer choice.